Hello, my good friends. My name is TTJ Kepsi Richard, and welcome to my online class. Today, our discussion on numerical and computational method will be on the continuation of finding at least one root of complex polynomial functions. The fundamental theory of algebra made us know that when we are faced with a complex polynomial function, that complex polynomial function will have at least one real root. That's it, will have at least one root. And we have several methods in finding those roots. We have the bisection method, the method of successive approximation, the false position method, the Newton-Raphson method, Anners method, the scanty method, among others. I have a video where we find solution to a complex polynomial function using the bisection method, using the method of successive approximation. Please check out that video on YouTube, or you can get that video at the end of this video. Today, before the video ends, we'll look at the method of false positioning, or the Regula Falsi method. So with the Regula Falsi method, we say that when we have a complex polynomial function f of s, that complex polynomial function have at least a root exists within this interval ab, where b is always greater than a. How do we find a and b? We find a and b using the location theory. Remember, location theory says that if we have a continuous function and we find f of a and it is equal to a positive number, and f of b is equal to f of a is a negative number and f of b is equal to a positive number, or vice versa, then at least a root exists within that interval a b close. That's what the location theories tell us. So with the method of false position, or the Regula Falsi method, that one root xn is giving us a times f of b minus b times f of a, all over f of b minus f of a. And remember, our a and b are the intervals we get using the location theory, and the f of b and the f of a are their outcome respectively. Now, after we get that first value of x, which may be x1, we try to find the outcome of the x1. What sign does it produce? Is it a positive or a negative? If it produces a negative, then it will replace our former a. If it produces a positive, then it will replace our former b, in that order, until we get up to a given iteration or approximations. So that's all what the Regula Falsi method, or the method of false position, is telling us. So we take some sample questions and see how we can put this into practice. So let's look at our first example. They say find a real root of the equation x cubed minus 2x minus 5 equal to 0 using the method of false position. Correct to 4 decimal place up to the third approximation. So that means you are going to do this up to the third approximation. Then we correct that to 4 decimal place. So what do? We know our function. So we say we should let f of x to be equal to the function x cubed minus 2x minus 5. Then we need to get the interval using the location theory. So let's find f of 2. F of 2 means 2 cubed minus 2 times 2 minus 5. So this 2 cubed is 8, 2 times 2 is 4, then minus 5. 8 minus 4, that will be 4. 4 minus 5 will be negative 1. Then let's find f of 3. Our f of 3 means we substitute 3 in place of x. So we get 3 cubed minus 2 times 3, then minus 5. This implies that 3 cubed is 27, 2 times 3 is 6, then minus 5. 6 minus 6 minus 5 is negative 11. 27 minus 11, that will be equal to 16. So you see that this produces a positive, negative outcome, and this produces a positive outcome. Then we can say that root lies between the interval 2, 3. I hope you get that. So the root lies between the interval 2, 3 close. So we need to get our we need to find our first approximation. And how do we find that? So we know that our A now is 2 and our B now is 3. Our f of A produces -1 and f of B produces what? 16. So remember, with the method of false position, our xn will be equal to A times the f of B minus B times f of A, all over f of B minus f of A. So now we substitute. So we can say our first approximation x1 will be equal to A is 2, so 2 times 16 minus B is 3, so 3 times -1, all over f of B, which is 16, minus f of A, which is -1. So 2 times 16, that will be 32. -3 times -1, that will be plus 3, over 16 minus -1, that will be 16 plus 1. So 32 plus 3, that will be 35 over 70. And 35 divided by 70 will give me 2.0588. So we know that our x1 is equal to 2.0588. Now we find f of 2.0588 and see the outcome that will produce. That means any place we see x here, we substitute 2.0588. So we have 2.0588 cube minus 2 times 2.0588, then minus 5. That will give me -0.3911. So you see that this produces a negative outcome. So what happened? It will replace the point that produces a negative outcome initially. So you see that our A, which is 2, produces a negative outcome. Then 2.0588 will replace that. So we can say that root now exists within the interval 2.0588 and 3. So what do? We use this. Remember, f of 2.0588 is -0.3911 and f of 3 is 16. We use that to find the second approximation. So since our root now lie between 2.0588 and 3 close, we can say our A now is 2.0588, replacing the former 2, and our f of A now is -0.3911. That's substituting 2.0588 into our function. The B still exists. So we can say that our x2, remember, will be A times f of B again from fixed position, then B times f of A all over f of B minus f of A. So now we find our second approximation, x2. So our x2 will be equal to, our A is 2.0588, f of B is 16, so times 16, then minus the B is 3, and our f of A is -0.3911, all over f of B, which is 16, minus our f of A now, which is -0.3911. So when we simplify that, that's 16 multiplied 2.0588, we get 32.9408. Then -3 times -0.3911 will be plus, so plus 1.1733. That's when 3 multiply that. Then this will be 16, this is negative, so 16 plus 0.3911. So that will be 16.3911. When we add 32.94082 1.1733, we get 34.1141. Then divided by this 16.3911. When we divide that, then our x2 will be 2.0813. What do? We find f of x2 to see which of these will it replace. Is it A or B? So now let's find f of 2.0813. That's substituting 2.0813 into our function. So we have 2.0813 cubed minus 2 times 2.0813 then minus 5. That will give us negative 0.1468. It produces a negative outcome. So what happens? It will replace our interval that produces a negative outcome, and it is the a that it will replace. So now, so we say now root lies within the interval 2.0813 and 3 close. I hope you get that. So we use this to find our third approximation, for that matter the last one according to the question. Remember, f of 2.0813 produces negative 0.1468, and our f of 3 is the same 16 again. So we use that to find our third approximation. So now we say our root now lies between the interval 2.0813 and 3 close. So we can find our third approximation. That's x3. So x3 will be equal to this times also 2.0813 times 16, then minus 3 times negative 0.1468 all over f of b, which is 16, minus f of a, which is negative 0.1468. So when we evaluate that, that's 16 multiplied 2.0813, we'll get 33.3008. Then this will produce positive, so plus 0.4404. When we add this 33.3008 to 0.4404, we'll get 33.7412. Divided by this will be positive, so plus 16.1468. So when this divide that, we'll get 2.0897. So since they say, the question says up to the third approximation. So when this divide, I remember to give us 2.0897. They say up to the third approximation. So when we reach the third approximation, we stop. So we can say, they say to 4 decimal place, and we have already approximated it to 4 decimal place. We can say a real root of x cubed minus 2x minus 5 is 2.0897. I hope you get that. If they say to the fourth approximation, you find the outcome of this and see which one to replace again in that order. We'll take another question and we'll see how we will solve it. So let's look at our second example. So use the method of Regula Falsi actually to show that a root 2x cubed minus 3x minus 5 equal to 0 is 2.2506. So how do we do that? So we can say we should let our function f of x be equal to x cubed minus 3x minus 5. So let's find f of 2. Our f of 2 will be equal to, and f of 3 will also be equal to. So f of 2 will give us negative 3, and our f of 3 is equal to 13. You see that they produce different signs. That means a root exists within the interval 2, 3, close, where our a is 2, our f of a is negative 3, our b is 3, and f of b is 13. So remember with the Regula Falsi method. So using the method of Regula Falsi, we should show that. Okay, so our xn is equal to a times f of b, then minus b times f of a, all over f of b minus f of a. So what do we do? Our a is 2, we substitute. F of b is 13, then minus, what's our b? Our b is 3, and our f of a is negative 3, all over f of b, which is 13, minus f of a, which is negative 3. So 2 times 13, that will be 26. Then negative 3 times negative 3, that will be plus 9 over 3 minus 3, that will be 13 minus negative 3, that will be 13 plus 3, and that will give us 16. 26 plus 9, that will be 35 divided by 16. 35 divided by 16 will be 2.1875. 2.1875. So what do? We find f of 2.1875 to see which of them it will replace. So we find f of 2.1875. That means we substitute 2.1875 in place of x in f of x. So that will be 2.1875 cubed minus 3 times 2.1875, then minus 5. When we solve that well, we'll get negative 1.0950. Since it produces a negative outcome, it will replace our former a, which is 2, which produces an initial negative outcome. So we can say that root now lies between 2.1875 and 3 close. And remember, our a is equal to 2.1875 now. F of a produces negative 1.0950. And our b is still 3. And our f of b is equal to 30. So we can find our second approximation. Remember, this is our first approximation, x1. So we can find our second approximation, which is x2. Remember, this will multiply this, so we'll get 2.1875 times 13 minus 3 times negative 1.0950, all over 13 minus negative 1.0950. So when 13 multiply 2.1875, we get 28.4375. And when negative 3 multiply negative 1.0950, we get plus 3.285. Then this will also give us positive. So it's like 13 plus 1.0950, and that will be 14.0950. When we add 28.4375 to 3.285, we'll get 31.7225 divided by our 14.0950. We'll get 2.2506. Now let's check what the question says. The question says that we should show that a root to this is 2.2506. So you see that we have gotten our 2.0506. There is no need to continue again in finding any approximation. So we just conclude that therefore a root to the polynomial function x cubed minus 3x minus 5 is 2.2506 as we are required. So as required. I hope you get that. So this is very simple compared to all other methods. It adopts a little bit of bisection. If you watch the bisection, we'll take a third example and see how we'll deal with it. So we want to solve our last example on this. But before we do that, please remember to subscribe to my YouTube channel if you are here to. Like and comment. Your comment keep me going. Now pause the video and try solving the question on the board. After that, you compare your answers with mine. Now compare answers. They say find a root of the equation x cubed minus x equal to 11 using the false position method and correct it to 3 decimal places with just 3 iterations. So how do we do that? Remember, we have our x cubed minus x equal to 11. This will be x cubed minus x minus 11 equal to 0. So we can say we should let our f of x to be equal to x cubed minus x minus 11. So now if we find f of 2, we will produce negative 5. And when we find f of 3, we'll get 30. So remember, with the regular Falsi method, our xn is equal to a times f of b minus b times f of a all over f of b minus f of a. And a and b are the interval. So since this produces negative and this produces a positive, that means a root exists within the interval 2, 3 close, where our a is 2, f of a is negative 5, our b is 3, and f of b is 30. So we substitute this into this to get our first approximation. So in substituting, we'll get our x1 to be equal to 2 times our 30 minus 3 times negative 5 all over 13 minus negative 5. I hope you get that. Now 2 times 13, that will be 26. Then negative 3 times negative 5, that will be plus 15. All over this will be plus 5. So 13 plus 5 will give me 18. 26 plus 15, that will be 41 divided by 18. And when 41 divided 18, we'll get 2.2778, correct to 4 decimal places. So now we need to find f of 2.2778. That's, we substitute 2.2778 into this. So we can say this is 2.2778 exponent 3 minus 2.2778 and minus 11. When we do that way, we'll get negative 1.4597. I hope you get that. So since this produces a negative, it will replace the a, since the a formally produces a negative. So we can say root now lies within the interval 2.2778 and 3 close. So now we know our a now is 2.2778, our b is still 3, our f of a is negative 1.4597, and f of b is 30. We substitute again to find our second approximation. Remember, the question says up to the third approximation. So our second approximation, x2, will be equal to 2.2778 times 13 minus 3 times negative 1.4597 all over f of b, which is 13 minus negative 1.4597. So when 13 multiply the 2.2778, we get 29.6114, and negative 3 times negative 1.4597 will be plus 4.3791. Then this will also give us 13 plus 1.4597, and that will give us 14.4597. So when we add 29.6114 to 4.3791, we get 33.9905. Divided by the 14.4597 will give us 2.3507. That becomes our second approximation. Now we substitute the second approximation into our function again to see what outcome it will produce. So we found f of 2.3507. So that will be equal to 2.3507 exponent 3 minus 2.3507 10 minus 11. When we do that well, it will give us negative 0.3612. Since it produces a negative outcome, it will replace the A now. I hope you get that. So we can say our A now is equal to 2.3507, and our f of A, remember, is negative 0.3612. That f of 2.3507. Our B is still 3, and our f of B is 13. So now we substitute this again to get our third and final approximation according to the question for that matter. So our third approximation x3 will be equal to, remember we are substituting to the formula again. So A times f of B, so A is 2.3507, f of B is 13, minus B times f of A, so 3 times negative 0.3612 over f of B minus f of A, so that will be 13 minus negative 0.3612. So when 13 multiply 2.3507, we'll get 30.5591, and this will give us plus, so 3 times 0.3612 will be 1.0836. Then this will give us plus 30, so this is 13 plus 0.3612 will give us 13.3612. Then when we add this to this, we'll get 31.0836 divided by 13.3612, and that will give us 2.3683, correct to 3 decimal places. Remember the question says up to the third approximation, so we are done here. But correct to, so we correct this to 3 decimal places. So correct to 3 decimal places. The root will be 2.368. So we said that a root to our polynomial function, which is x squared minus x equal to 11, is 2.368. I hope you get it. So please, let's correct. If 30.5591 is added to 1.0836, it's rather 31.6427. And when we divide it by 13.3612, that's why we got the 2.3683 as our figure. So it's only this that was wrong. So correct to 3 decimal places will still be the 2.368. So we'll end it here today. Please remember to subscribe to the YouTube channel before you sign out. Like and comment. Please share my videos. This will make YouTube suggest my videos to others, and I can record more mathematical content for you. Until we meet again, my name is Kepsi.